Good morning, my lovely 13s. Right, buddies, here we go. It's our last lesson, well, our last taught lesson anyway, on projectile motion today, you lucky ducks. And so the final thing that you're going to learn today is called the equation of trajectory. Now, my lovelies, I would tell you that this is a really cool and really useful formula that you're going to end up using a lot in real life and stuff, but the truth is I don't really think that it is. I think that the only use really of this formula is for you to kind of practice using the regular projectile motion formulas like the Subat and the Sut, but in complete generality. So I didn't know this formula existed until I started teaching this spec and the old spec, the equation of trajectory. Yeah, but it is useful in that it allows us to practice our amazing kinematics skills. So it will stretch your mind on kinematics, so which I suppose is a good thing. So hooray, my lovelies! The title is the equation of trajectory. Now, boom, there they are, buddies. Oh my good God. Okay. Now here's what it is. We've got y equals x tan theta, take gx squared over 2u squared cos squared theta, which is best for variables. And then you got this one here where the cos theta, of course, is moved to the top as a sec squared theta, which you know you're allowed to do just because they are reciprocal functions, so it can pop up to the top. So what I would suggest you do is just jot these guys down right now, just the two of these. So go ahead and pause the video and do that. Yeah, and I'll go through what they are. So it's essentially, if you know what these formulas are, you can solve equations with them, and yeah, I guess that's their main use. Now, they're not super useful, but they're challenging to derive, and I think that that's why you do it. So if I were you, I'd jot these down, including all of these labels I put for you. You ready? Go. Okay. Now here we go then, buddies. Just so you get how this formula works, essentially, I'll show you in a picture in a sec, but the y value is how far up something ends in the middle of a projection. So if you shot something from the ground and it went up in a great big arc like this, it went whoop, up in a big arc and landed again, at any point, the height of it in that arc is given by y, the vertical height. How far along it's gone from where it was projected is given by x. And u is actually the velocity that it was shot with. So I suppose the advantage to this formula is that the u doesn't need a direction. So if something was shot in the air at 20 meters per second, you wouldn't need to know that it was 20, 30, whatever I just said, 20 meters per second, like 30 degrees above horizontal. You wouldn't need to know that because the u in this formula has the direction already accounted for because of these thetas. Cool? Theta is the direction above horizontal that something is shot. Cool beans, cool beans? Now, as I say, these aren't super useful, but you do sometimes get them on your exam. And you could memorize them if you want to, but usually the questions are asked in such a way they want you to derive them. And I don't know about you, but I don't really want to memorize these. And while I maybe do have them memorized, it's only from teaching it year after year after year. If I was you, I wouldn't memorize them, but I would learn how to derive them. And so that's what today's lesson is about. We're going to derive the two of these, and then I'm going to give you a bit of practice, and that should be that. Cool beans. Right then, so here we go. Let's derive them. So what I've got here in the blue square is just them, so you can remember what they were. And here's how it works. Just say you had a particular object here, which I've just drawn as a little black circle, and it's shot up at a certain angle above horizontal. Well, if it got stuck in this tree here, which I've only just drawn on the picture to give us a particular reference point, it would be over a certain distance x and up a certain distance y. That's what all the variables do in this formula, okay? That's where these variables come from. Now, the formula is valid for all the parts on the arc, though, and the path that it would follow. So the same formula applies for this point, or that point, or the maximum height, the maximum height as well, where the vertical velocity would be 0. In the tree, it's valid for there, it's valid for, and it's valid even on the floor. But if we want to come up with a general formula, you pick somewhere on the arc that has nothing special about it. So that's why we picked here, okay? There's nothing unique about that. It's not the maximum height where velocity is 0. It's not this final where it hits the floor again, where the vertical displacement is 0. It's just somewhere, okay? Now, I'll bet you you probably, I'm gonna take a risk here if you want, you could probably derive this formula without me. I believe that this bottom one is the one that comes out if you do it exactly as you think. So if I lay out the first step and then I'm going to give you the option of just going ahead and seeing if you can prove the formula without me, that's cool. And if you'd rather do it with me, that's cool as well, because you'll just have to repeat it over and over and over in your practice today anyway. So here we go, buddies. Let's try to derive it. Okay? Now, what I'd suggest then, buddies, is if we're going to do an equation for it, you see it's got y and x in, okay? So it's got vertical and horizontal in. The variable that it doesn't have is time, okay? So of all of the SUVAT equations, the thing that's not there is time. So what are we going to do? Well, we're going to do like we do on all projectile questions, on all kinematics questions, and we're going to define a direction to start with. So let's think about horizontally. Hor! Pick a way to be positive. Right! Because it's shooting to the right. Now, horizontally, you guys know that projectiles stay at constant speed. So it's not SUVAT, but SUT. So we have SUT there. So it's just speed equals distance over time formula. Cool. Now, what was S defined as when we were given all of our variables earlier? What would we call S, the horizontal distance? Well, yeah, we called it X, actually. So instead of having it as S, like we normally do, it's X, because we're just using it as a standard variable. Like in biology or physics, you might like have V naught and stuff like that. You might have seen stuff like that, or R naught and stuff like that. Yeah, anyway, so that we're just using X to represent S. U, the initial speed, well, horizontally, what is the initial speed? Because diagonally, it's U. What is it horizontally? Like, what is it for this part? Well, yeah, you got it. It's just U cos theta. U cos theta. Still positive because it's shooting off to the right. In time, we don't know. So there you go, my buddies. That's what's weird about that. Cool. Now here we go again. That's all we got for horizontal. So let's go for vertical next, okay? Vert. Pick a direction to be positive. Now, I'm going to force it to be up as positive because that's how you get the signs to match out on these guys. Okay, normally it doesn't matter, but if we're trying to come up with these specific formulas, you'll notice that in front of the G, which you know is acceleration, there's a negative there. That means they've picked up as positive for these formulas to work. So if we want to come up with the exact formula, not the negative opposite of it, we're going to have up as positive. SUVAT. Cool. Now, here we go. SUVAT, because it's accelerating vertically. S, the displacement vertically. Do we know what that is at the top of our tree there, at our generic point in the middle? Well, yeah, they called S Y. Do we know what U is? The initial projection speed, but upward. Well, yeah, it's going to be U sine theta this time. U sine theta. Cool, which is positive because it's upward. Do we know V? Nah. Do we know what A is, though? Yeah, it's a projectile, so it's operating under gravity. So A is going to be negative G, negative because it's down. And do we know T? Nah. So that's where we're at, okay, my buddies? Right. I'm going to spoil it for you right now. Here's what I want you to... I'm not going to spoil it for you, actually. I'm going to make you do it instead of me to give you the opportunity, because I worry that this lesson might be a little bit boring if you don't get a chance to do stuff. So here's what I'm going to say. Your strategy on this, my buddies, is to... get the form, you know what you want y as the subject, right? Use the vertical one first and get this as the subject, okay? Because that's going to be y as the subject. We don't want anything to do with v, so pick the one that hasn't got v in, okay? And yeah, get this guy, a formula that doesn't have v in on the vertical. Now horizontally, do the same deal again. Combine the two equations and get that. If you think you can do it, push pause and go. And if you've stuck with me, that's cool too. So if you stuck with me, let's do it, my buddies. To start with, what we're going to get here, let's do horizontal. I know I just said do vertical, but let's do horizontal. We know S equals UT, yeah? That's the formula that we're dealing with, S equals UT. But S they called X, so we have X equals, U is actually U cos theta. Cos theta times T. But it's weird, I need a bracket around it if I write it like that, because it looks like the theta's been times by T, not the whole thing, so better to write it like this. U equals UT cos theta. Okay, and there we go. Well, actually, I don't want to underline it. That's as far as we can get, and that's the formula for X. Now, vertically, buddies, here's the thing. I know for sure horizontal and vertical are linked through t. So I'd like, because both of them depend on time, how far over it's gone, and how far up it has gone, are both linked to how long it's been in the air for. So vertically, let's do it. I want the one that doesn't have v in it, because v is not in this formula, and yeah, it's useless. We don't want v. Okay, so you ready? The formula without v in suvat is s equals ut plus 1/2 at squared. Okay, using the variables that were given though, s is actually y, u is actually u sine theta, t, plus 1/2, a is actually minus g, t squared. Cool? Which means y equals ut sine theta, take away 1/2 gt squared. Okay, so we have two formulas that are stuck, but neither one of them look like this. What do you think we should do? What is the not common denominator really, but what is like the common denominator between these two? How do we put them together? Well, yeah, they're both linked by t. So here's what we can do. Back to the horizontal. Switch color to show I'm in a second phase of it now. I want to get the purple one, or I want to get this into there. So let's make t the subject. That means t is going to be x over u cos theta. Right? Right. And what we can do then is we can pop this bad boy in. So put that one in. That can be 1, 2. We can put 1 into 2. 1 into 2. Because when you do that, check it out. You get y equals u. T is actually x over u cos theta, sine theta. Take away 1/2. G, and t, again, is x over u cos theta, but this time squared. Cool beans, buddies. Okay, sweet. So, here we go. Next line, then. Well, we got some cool stuff happening straight away, which is great. Use cancel in this bad boy. And this one here, no canceling. That's rubbish. That's all right, though. Use canceled off the first one, so let's see what we got. Or let's see what we've got. Well, here we go. We're going to get y equals, and we're going to be having an x, right? But it's going to be sine, it's going to be x sine theta over cos, I'm going to just write it out. We're going to have x sine theta over cos theta is what that simplifies to. Now, on the second one, here's what we're going to get. We're going to get, well, actually, now that I've written it as extra steps, let's square this one. So I'm going to get an x squared, a 1, and a g on the top. So on the top, we're going to get gx squared. Cool beans? And on the bottom, what we're going to get then is a 2 from here. So it's going to be 2, then u squared, cos squared, theta. Now, if you're kind of spotting anything at all, we're getting pretty close here. This is looking remarkably like the top one, isn't it? Yeah, it is. So, one final step then, my buddies, and then you got it. Sine theta over cos theta? Well, yeah, tan theta. X tan theta. Take away gx squared over 2 u squared cos squared theta. Badoosh, you've just proved it. So that's the equation of trajectory. That's where it comes from. We've exactly matched it. That's brilliant. There's an alternate though as well. You guys remember that what's sec squared theta equal to? Well, yeah, it's 1 over cos squared theta, right? Which means, my buddies, or just sec theta is 1 over cos. Actually, yeah, I could have just said sec. I'm going to bin off the squareds. Sec theta is 1 over cos theta, right? So this is going to be like 2u squared, open bracket, 1 over cos squared theta, which means I can times the top and... I don't want to do it that way. I think I'm just going to explain it easier. You can move cos to the top because these are inverses of each other, right? So 1 over cos squared is going to be the inverse of sec squared, which means I can just rewrite it in the other format, just to not confuse. I don't want to make, let's not muddle it, let's just get on with it. X tan theta equals, X tan theta, take away gx squared sec squared theta over 2u squared, and that's it. And there's the other format. So boom, both variants of the equation of trajectory, bish bash bosh, done. Now, I think you could totally do that. So gx squared is x squared theta, beautiful. Now you can totally do that then without my help, I'd imagine. I bet you could have done that all by yourself. If it was just a question of the exercises, you probably would have got it. And there you go. That's your equations of trajectories, my lovelies. And boom, that's pretty much what you're going to do today is practice them. Now, you don't often need them, but as we're using them, and oops, we don't often need them, but as we're using them anyway, may as well use them in the questions. So let's see. When you've got them, these simplify the questions a bit. It simplifies them out a bit. So here we go. A basketball player throws a ball in a net which is 3 meters horizontally and 1 meter vertically above the player's hand. The ball is thrown at 50 degrees to horizontal. And how fast was the ball thrown? So we're after you. Now, my buddies, which one do we want? Well, I wouldn't use these, but here you go. This top one is the better one for variables because, well, the trig is just everywhere. And yeah, if you're just going to pop a number, it doesn't matter where the trig is. So let's do it. Let's check it out. So here we go. Well, first things first, it's got to go 3 meters horizontally and 1 meter above. So in our formula here, y then is good. Should I lift them? I'm going to list them out. Oh yeah. I'm trying to cut steps out and I really shouldn't be. Okay, here's our givens. Y is going to be 1 meter because the ball ends up 1 meter higher than what it was thrown at. The x is how far along it goes, 3 meters. Theta is the angle of projection, 50 degrees. And I believe that that's it. We want how fast was it thrown, so that's your question mark there. Now it's just a number chug game, so let's do it. Let's chug some numbers, my lovelies. So check in the first one. It's going to be 1 equals 3, 10, 50. Take away 2, or take away g, 9.8. That's what g is. X was 3 squared over 2. U, which is what we want, u squared cos of 50 squared. So there you go. What I would almost suggest, see, I don't like these equations. It's hard for me to hide my bias. I think the equation of trajectory is useless. There, I've said it. But anyway, let's keep going. Let's do this as easy as we can. I'm just going to carry tons of decimal points because I don't want to have a horrendous... I want this to be simple. I want to get it in the minimum number of steps. So I'm just going to carry tons of decimal points. This is physics, not maths, so I'm able to round. So here you go, 3, 10, 50. It's just going to be 3.575. So 4 sig figs, 3.575. Take away, and I'm going to put all of these in together. Into my calculator, I'm going to push fraction button first, then I'm going to go 9.8, then I'm going to times that by 9, because that's what 3 squared is. On the bottom of the fraction, I'm going to go 2, then I'm going to go times by, then open bracket, cos 50, close bracket, close the cos's bracket, all squared equals. Now, that means here I've got 106, 6.7, because this, and this all made that, and the little poor u squared is just chilling on the bottom. Cool beans? Right then, let's do some rearranging. 106.7 over u squared, so I'm moving it to the left. And let's move the 1 to the right equals 2.575, because that's that, take away 1, which means that 106.7 equals 2.575 u squared, and here we go. U then is equal to, and let us do it, it is going to be the square root of fraction button, and then it's going to be 106.7 over top 2.575 equals 6.44 to 3 sig fig. 6.44 meters per second as the initial projection speed. That should be the final answer. A bit clunkier than just doing it normally, but we did get the right answer and we did successfully use the equation of trajectory. Now I carried 4 significant figures, so I should be safe to 3, but certainly safe to 2. So the answer will definitely be 6.4 at least, so we have enough accuracy. Cool. Right, so let's do an awkward one, and then let's call it a day of equation of trajectory, and I'll give you a practice lesson next lesson where you can practice lots of stuff that isn't equation of trajectory, that is just regular stuff. Okie doke. So here we go. A boy is standing on the beach and his sister is on top of a cliff 6 meters away and at a height of 4 meters. He throws an apple with a speed of 10.5 meters per second. In which direction should he throw it? So we were after theta. Cool. Now, here you go, my buddies. I think you should just do it. I'm going to give you one hint, and the one hint I'm going to give you two hints. This is a trig identity. That might come in handy. That's the one hint. And the other hint I'm going to tell you, my lovelies, is quadratic, my folks. It's going to be quadratic. So you're ready? We're going to use the bottom one, because this one's better for trig, because all the trig stuff's on the numerators, so it's going to be easier. So you ready? Go, all by yourselves. Okay, and for you guys who stuck with me, let's see how to do it. So first things first, boy standing on the cliff, blah, 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 blah. He's 6 meters away, so he's 6 meters away from the sister, and it's at a height of 4 meters. So let's do it. So first things first, he's at the height 6 meters away. So 6 meters away, that's going to be x, okay? Because it means 6 meters horizontally, because it does say that the height, which is y, is 4 meters. We're given that u is 10.5 meters per second, and in what direction should he throw it? Now that's theta. That's what we're after. Cool beans. Now we know that it's the bottommost equation of trajectory, which is going to be better to use because all of the trig is on the top. So it'll just avoid some awkward rearranging. So it's good to use the bottom one, so let's use that. So to start with, let's do it. Well, here it is. It's going to be y equals, so 4 equals x tan theta, 6 tan theta, minus, and let's see if I can remember it, g, which is 9.8, gx squared, so 6 squared sec squared theta, all over 2u squared, I believe. Let me just check, because as I say, I don't have it memorized. You can just derive these or not use these formulas at all. Gx squared sec squared over 2u squared. Gx squared sec squared over 2u squared. Yeah, no problem. Okay, now because it's physics, let's go ahead and just tidy it. Let's put some numbers to it. So 4 equals 6 tan theta, and I'm going to put every single number, 9.8, 6, 2, and 10.5 in my calculator. Let's do it. So 9.8, or fraction button first. Fraction button, 9.8 times 36 over 2 times 10.5 squared equals 8/5 I've got. Oh, that's nice. Oh, so it's like, oh yeah, that's brilliant. Oops. Yeah, that's brilliant. Or 1.6. I want to call it 8/5 actually. I can't resist. I'm a mathematician at heart. I'm going to put it as 8/5, even though I just said let's put a bunch of decimal numbers in. Let's do it anyway. So take 8/5 sec squared theta. Okay. Now, we've got tan theta here and sec squared theta there. So basically, we're okay though. They're two different trig ratios. But sec squared is 1 plus tan squared. It's one of those weird reciprocal trig relationships. So let's do it. 4 equals 6 tan theta. Take away 8/5. And this is going to be 1 plus tan squared theta. Okay. I've had enough with the 8/5. I don't like having a fraction in, so I'm going to times both sides by 5. 20 equals 30 tan theta, take away, and I'm going to expand the bracket, remembering that the 5 isn't there, minus 8 tan squared theta. So there's where we are at, I think, my buddies. Cool. I've got tan squared and I've got tan in the same equation, which means we're quadratic. So I'm going to put everything left so I can have my tan squared as positive. So 8 tan squared theta, take away 30 tan theta, and then I have 20 take away 8, which is going to be 12. So then we're going to be take away, no, we're going to be plus, no, hang on, I did that wrong. Oh, that was lucky, I spotted that. Just about to make a mistake. 28 plus 8 then is going to be 28. Plus 28 equals 0. Now, I don't know if this will factorize or not. It might well do. It's 14 and 4. I kind of don't want to factorize it just because I'm worried that it might be tricky. Should we do it? Are we curious? Okay, I'll go on. We're curious then. Okay, let's half everything because it's all even. 4 tan squared theta. You know, you can just use the quadratic formula here, right? Minus 15 tan theta plus 14 equals 0. Okay, let's just have a quick check. Times plus two numbers that times to make 4 times 14, 56. Two numbers that times to make 56 and add to make minus 50. Oh, by Jove, it worked! Is there two numbers that time? Oh, I'm glad that we did that now. This has been a day of results, my lovelies. That's a result. Okay, is there two numbers that times to 56 but add to minus 15? Yeah, minus 8 and minus 7. I would have just gone with quadratic formula. So, yeah, nice one, buddies. That's brilliant. Okay, so let's do it. So, let's not cut any steps now. I'm in the mood to not skip steps. 4 tan theta, split the middle term, and we're going to get minus 8 tan theta minus 7 tan theta plus 14 equals 0. 4 tan theta is common in the first two. 4 tan theta, leaving you with tan. Theta, take away 2. In the second one, minus 7 is common, leaving you tan. Theta, take away 2 equals 0. So it factorized 2. Tan theta, take 2. And 4 tan theta, take 7 equals 0. And oh my good heavens above, the big question. Which means either that tan theta equals 2, or that tan theta, move the 7 over, becomes 7 over 4, which means that theta is equal to, what's it equal to? Shift tan of 2 is 63.4 degrees. 4 degrees, which seems reasonable, or theta equals shift tan of 7 over 4. Here you go, 60.3. Now, here we go. This is a funny old one, my buddies, because we have two answers, and normally, when we do a mechanics question, only one of them is valid, okay? But actually, in this case, both answers are an answer. Now, I'm going to tell you why both of these are valid, so you don't discard either. They are both right. It just depends on how the sister caught the ball. So if you think of it, my buddies, the sister could catch the ball on the way up or the way down. So essentially, if, oh, how will I draw it? There she is up there, okay? And here she is, ready to catch a ball. Okay, so there she is. Look at her. She is delighted to be catching a ball with her brother. And look at that. There she is. She's so happy. And there's the brother down there. And here's the thing. If he threw it at the first angle, okay, so I'll do that one in red. If he threw it at 63.4, here's what the ball did. It would have gone up like this, peeked out, and she would have caught it in her hand like that. So her hand would be out to catch it like that. Okie doke. Whereas if he threw it at the lower angle, which I'll show you a picture in green, the 60.3, he's thrown it like this instead. Oh, I've drawn it poorly. He's thrown it like this instead at a lower angle. He's thrown it so it goes like that, and she actually catches it that way on its way up, because that one would have done that and then come down there. So essentially, she's caught it on the way up, so her palm would have been down to catch the green one, but her palm would have been up to catch the red one, and that's why you got two answers that are both valid. How exciting, my lovelies! So, equation of trajectory, it's cool because it gets you to work completely in generality. Not super useful, I have to say. I don't think it is anyway. Maybe someone can correct me if I'm wrong, but it's great because it gets you to work in complete generality. If you take engineering or physics or whatever at university, you'll do a lot of this working in generality stuff. So, yeah, pretty much, when you get off to university and you have to put a number in, you'll be like, good heavens above, who puts numbers in anymore? Because you'll work completely in letters, and that's what this skill practice is. So, happy, well, apart from this question, but happy days. Cool. What I'm going to get you guys to do then is these guys here. Page 123, question 1 to 8. Lots of them ask you to derive it. Just practice deriving it. Derive a whole bunch of them. Just do whatever the questions ask, and you will get really good at this. That's it from me. Next lesson I'm going to give you is going to be a practice lesson where you can do all of the projectile skills, and then we get to move on to the brand new unit. So keep up the good work, Super 13s, and I look forward to seeing you in person again next week. So that's it from me. Bye, buddies!